There are two cases where you may choose to use logarithmic differentiation. The first is where logarithmic differentiation would make your work a lot easier to do, but is not actually necessary to use logarithmic differentiation. And the second is where logarithmic differentiation is necessary to solve the question. Now, the not necessary examples will look like some nasty combination of product and quotient and chain rule all wrapped up into one question. Something like this, it's not necessary to use logarithmic differentiation. If you remember all those other rules, you would start with the quotient rule, and then when you have to take the derivatives of the numerator and denominator, you would have product rule and chain rules inside them. The answer will get quite big and nasty, but it's still possible. But there are cases where logarithmic differentiation is strictly necessary, and that's in cases where what you're trying to differentiate is a function to the power of another function, like an f of x to the power of a g of x. For example, x squared plus 2 to the power of x cubed plus 3. So in this video, we're going to be looking at how you would solve this question and how you would solve this question using logarithmic differentiation. So let's start with this one. Okay, so we have y equals x squared plus 1 to the power of 9 times e to the 3x divided by x to the 4 plus 1 to the power of 7. Well, it starts by taking the log of both sides. So taking natural log of both sides, like this. We have natural log of y equals natural log of this function. Now, the reason we wanted to do this is because we have all these log laws that would allow us to separate this function into a sum of a bunch of pieces, and each of those pieces are easier to differentiate than this function as it currently is. So let's continue. We have natural log of y. Applying the first log law, the one for natural log of a over b, what we get is natural log of x squared plus 1 to the power of 9 times e to the 3x minus natural log of x to the 4 plus 1 to the power of 7. The next log law we can apply is about this product inside this log here. And it looks like this. Natural log of x plus 1 to the power of 9 plus natural log of e to the 3x. And before we start differentiating, there's one more log law that can be applied. This power of 9 can be moved down in front, likewise for this power of 7. And also natural log of e to the 3x can be simplified. So let's perform those operations before we actually differentiate. Natural log of e to the 3x is 3x. And also bringing down to 7, we get 7 times natural log of x to the 4 plus 1. Now this is helpful because when we differentiate, differentiating natural log of y, we get 1 over y times dy dx. Don't forget your dy dx from the implicit differentiation, and that should be an x. So differentiating here, the constant 9 stays multiplying. Differentiating natural log of x squared plus 1, we get 1 over x squared plus 1, and now by the chain rule we multiply by the derivative of x squared plus 1, which is 2x. Differentiating 3x, we get 3. And in this one here, the derivative of natural log of x to the power of 4 plus 1 is 1 over x to the power of 4 plus 1 times the derivative of x to the power of 4 plus 1, which is 4x cubed. And we're almost done. We just want to solve for dy dx, so we're going to multiply across by y. And we have y times all of this stuff, so let's maybe just combine some of these expressions. We have 2x divided by x squared plus 1 here, plus 3 minus 7 times 4x cubed over x to the 4 plus 1. And we don't want to leave that y in the answer. We started off with y equals this function here, x squared plus 1 to the power of 9 and so on. So we're just going to replace this y with what it is as a function of x. So it's x squared plus 1 to the power of 9 times e to the 3x divided by x to the 4 plus 1 to the power of 7. That was our y, and that multiplies by, let's multiply these numbers. 9 times 2 is 18. This is just 3. 7 times 4 is 28. And and divide it by x to the power of 4 plus 1. So this differentiation that we had to do in this line here, that was much easier than the differentiation we would have have to have done back here. We would have, first of all, a quotient rule, and when it came time to differentiate the numerator, we would have a product rule. Within that product rule, we would have chain rules to do. Likewise, we would have a chain rule in the denominator when we have to do that one. So just knowing your log laws, how to deal with log of a over b, log of a times b, and the power rule, just to simplify your expression before you start, it can make your work much, much easier. And that's one of the times that you'll want to use logarithmic differentiation. The other time that you'll want to use logarithmic differentiation is when you have a function to the power of a function. So it starts off the same way. We take the natural log of both sides so that we get natural log of y equals natural log of x squared plus 2 to the power of x cubed plus 3. This time the important log law is the one that allows us to bring the power down in front to multiply. So natural log of y equals x cubed plus 3 times the natural log of x squared plus 2. And now when we differentiate, we're just going to use the product rule here. So differentiating across the derivative of natural log of y, again, is going to be 1 over y times dy dx. Here we use the product rule, so we get x cubed plus 3 is going to multiply by the derivative of natural log of x squared plus 2, which is 1 over x squared plus 2 times 2x. Then we add natural log of x squared plus 2 and multiply by the derivative of x cubed plus 3, which is 3x squared. Now we're almost there. Again, we want to multiply across by the y, so that we have dy dx equals y times x cubed plus 3 multiplied by 2x over x squared plus 2 plus 3x squared times natural log of x squared plus 2. And the final step, just like before, is to replace the y here with what it originally was, x squared plus 2 to the power of x cubed plus 3. So replacing that y, we get x squared plus 2 to the power of x cubed plus 3 times 2x times x cubed plus 3. That's just multiplying the x cubed plus 3 onto the 2x. Denominator was x squared plus 2 plus 3x squared times natural log of x squared plus 2. And that's the second case that you'll use logarithmic differentiation.